All right, class.
Yes.
Wow, you guys don't sound very enthused. Let's try this again. All right, class.
Yes.
All right, that's better. A little bit better. Okay, for all you people following along and paying attention, this one is kind of annoying because it's a lot of words, but then it will make sense at the end, hopefully, if you guys are following along. So we're going to talk about percentiles and quartiles. Percentile and percent of the items in a distribution are less than a particular data item. We say that the data item is nth percentile. All right, so we're breaking this up in quarters. This one right here. Is that the third quarter? Say yes.
Yes.
Is each one's a quarter? That's a third quarter. What percent is the third quarter? That one's going to be the 75th percentile. That's where we get that from. 75th percentile. Make sense? Okay. So if we break it up in quarters, what about, let's go down over here. What if we go way down over here to the first quarter? That's going to be? Okay, so that's 25th percentile. So now if you think of it like a group of 100 people, and we're talking about test scores. Group of 100 people and test scores. If you're in the 75th percentile, if you guys take the SAT and ACT, you actually get results that come out, something like that. And it says you're in the 75th percentile. That means that you scored better than 74 other people. Does that make sense now? If there's only 100 people left there, there's only 100 people in that survey or the study, if you're 75th percentile, that means there's 74 people that scored below you. Does that make sense? Or nonsense? Okay, so if you're the 25th percentile, how many people scored below you? 24, right? Because there's only 100 people in the group. If you are the 25th, that means that there's 24 others that got below you. Make sense? Okay, good. All right. Z-score and table, you can find percentage. We'll deal with this later here in a moment. Actually, I think we deal with this next unit. Yes, next unit we actually do the tables. Right here. Statisticians use properties of the normal distribution to estimate probability that a result obtained from a single sample reflects what is truly happening. I told you guys, this is my least favorite time of the year because two things. Pumpkin spice everything and elections. All that you see all the time is politicians telling you how great they are and how bad their opponent is. And so we have people on the news saying, hey, there is a percentage this people will win. And they're showing polls, they're talking about percentages. We're going to talk about that. And in our surveys, we're going to deal with the 95th percentile. So that's 2 standard deviations. 95th percentile is 2 standard deviations. Now, if we find something like that, and you guys are thinking about it, think of that TV commercial or the news show that says, hey, this poll says someone is winning with something percentiles, right? And there's always going to be like a little plus or minus right there. Now, they're talking about the confidence interval. Confidence interval is normally 95%. So they could say with 95% confidence that their answer is correct. That's what we're trying to get at. 95% confident. Now, let's say, for instance, we're betting on the basketball game later today. Who's playing today? Lakers. Are we betting on the Lakers or against the Lakers? You're betting on? Okay. So, what confidence do you have? How confident are you that the Lakers will win? You're not confident at all, right? Exactly. So that would show a low confidence rating. So do you think, who are they playing against? Pelicans? Oh, yeah. Okay. Anyway, so in that case, the Lakers might win. Okay? They might win. So how confident are you of them winning? Low confidence?
Yeah.
Or are we talking about less than 50%?
Yeah.
So that's what we're talking about here. When we do this data, the confidence interval means how strongly we are saying that our data is right. That's what the confidence interval is for. So 95% probability that it lies within here. Now, what this is, where n represents the sample size. How many people or how big is the size in this poll? And it's always going to be plus or minus times this to get the margin of error. I know someone's going to ask me how to do this later on, and I'm going to point them to this slide that they did not highlight, circle, or underline. Because you're going to ask me for the formula, and I'm going to say, nope. I'm going to say, look at your notes. In a survey with a random sample of 1,000 U.S. adults, 46% of those questions said they dread public speaking. Verify the margin of error that was given for this survey. Now, first, the margin of error is what we have to calculate, and we're going to talk about upper and lower bound with that. Plus or minus 1 over the square root of, what's my n value? 1,000. Yes? And we're going to take that and times what? 100%. So it's going to give me my percent. So control, divide 1 over 1,000. Square root first. 1,000. You notice I'm not doing the plus or minus. The plus or minus tells me that I'm going to have a positive answer and a negative answer. So there's always going to be 2. So I just need to figure out what my number is. And then times 100. So what is my margin of error? 3.16. 3.16%. I'll show you what we do with that. So my minimum would be 46% minus 3.16%, which is going to give me, what's that, 42.84%. Because this is plus and minus, isn't it? So the minimum goes with the plus, and the maximum goes with the, wait, did I say that backwards? Minimum is minus, maximum is plus. Would be 46% plus 3.16%, which is going to give me 49.16%. Now the polling and the surveys that we're talking about are always wrong. The polling is wrong because if we're talking about U.S. adults, that currently is over 300 million adults. And you think a sample size of 1,000 is enough to actually identify and get everyone's opinion of what they think? So when they actually talk about this poll and they're saying that this is a sample, they can't be accurate. They're trying to be close, but they're not. They're saying with a 95% accuracy or confidence, so they're 95% sure that their answer for the entire population is going to be between there and there. So that's what we're doing here. We're not checking it on the phone because that's not what we do. We take out our notes because we get graded on them notes, right? So with a 95% accuracy, that's what we have. Yes? Does that make sense?
Wait, where'd you put your 160?
When I did the math right here? Did you do this math on the calculator?
No.
Okay, that's where I got it. So 1 over the square root of 1,000 times 100. Here, I'll show you. Right there.
Where's the square root?
See where it says control, then trig, then down below is x squared? But my x squared is blue, right above it, right? I believe yours is yellow, so it's control x squared.
Oh, okay.
Okay? There we go. Does that make sense or nonsense?
So it would be 3.16.
116, yeah.
Maybe 31.
Huh?
I got 31.6.
Because you were missing a 0. Or too many zeros. Because it's supposed to be 1 over. 1 over is a fraction. You want me to show mine again?
Yeah.
Look. 1 divided by the square root.
Oh, okay.
Alright. So let's go ahead and take a look at B. Write a statement about the percentage of adults in the U.S. population who dread public speaking. So, we did this on the first one. We said that because I already solved it and then I got this. So, my margin of error is here, and then my minimum was it 42 point and max 16, right? So between and 49.16%, we are, our confidence is 95% confident that the poll is correct. Actually, let's see if I could actually pull up some. All right. Okay, so let's look right here.
No.
You guys are almost done?
Yeah.
Because I want to show you. All right, I just Googled one that had a picture. All right, so I'm going to show you because you're going to see this all the time. That's why I hate this time of the year. So it says the people from this poll. Okay, it didn't say the amount of people they polled, which would probably be better if they were to show, because you could look at it and say, hey, did they only poll 100 people? Did they poll 10,000 people? So the size of their sample, it will affect this. So governor's race is voting now. So Hobbs is 46%, Kari Lake is 47%, and some undecided not to vote 7%. So if you look at the bottom, whenever you're looking at this, it's going to be a plus or minus. So that's plus or minus 3 points. Their confidence on this one. So if we're talking about Kari Lake, she can go as high as 50, but then down to as low as 44, right? And Hobbs, it can go as high as 49 and go down to as low as 43? Yeah, 43. So everything in this poll, what they're talking about is the undecided, which is going to affect it. So whenever you see these things all the time, you have to look at this. Okay, I'm trying to make everyone at least smarter for, this reason. All right, so let's take a look at, I think there's another example, isn't there? Ooh, yeah, right here. So on this graph right here, it says population distribute weekly earnings United States. Now, is this a bell curve? Say no. No, it's not a bell curve. It's not symmetrical, is it? It looks like it is piled up on the left-hand side, but pointing to the right. So it's piled up on the left, it's pointing to the right. So if it's pointing to the right, that means it's going to be skewed to the right. So these ones are skewed to one side or the other. Skewed to the right. Yes? Sure. Now, what do you think if it was piled up on the right-hand side? It would be skewed to the left. It would be skewed to the left. Okay, right here it says, okay, so relatively few people with very high weekly incomes pull the mean income to a value greater than the median. Okay, the median's right here. The mean is higher than that. And the mode is on this side. Okay, most frequent income modes occurs towards the low end of the data item, so that's below the median. This is called a skewed distribution because a large number of data items are piled up at one end or the other with a tail at the other end. So what I say is it's pointing this way, so it's skewed to that way. Is that sense or nonsense? It's almost like trying to keep someone off their freaking phone and I have to keep telling them to put the phone away. Anyway. Anyone got questions over this about skew? We're going to talk more about skew in the next section, but we're done here. I'm going to let you guys work on the homework, so make sure you guys like, share, subscribe, hit that notification button, and support my channel, buying my merch store. Michael's going to work on some new sock design for me. So